everyone. And, it's okay. Um, so what we will will and what we will do also that works better. After that, we will do the next part of our lecture, which is data analytics for the supply chain innovation. And yeah, I see that you have your computers. It's good because we will use computers. So it will be some exercises. We will do them together. And yeah, so this is the program of today. But before starting with supply chain analytics, we will discuss a bit the paper the same way we did for the first one last time. Perhaps a bit of a reminder. So yeah, this is really important, and we should have it in mind because it is a kind of framework that we should have. We said that business model innovation can influence supply chain innovation, right? So, and this is something we did last time during the lecture, but also the workshop is about this. In order to come up with innovations in the supply chain, we can change the business model. And this is actually coming from Albjörn's framework, right? Albjörn and Al's framework. The one where we have supply chain structure, in and supply chain technologies and supply chain business processes. So these are the features or dimensions of supply chain innovation, and they are in the context of the business model, right? So this is the framework that we have done, and therefore the business model will have influence on the supply chain structure, perhaps also on supply chain technologies and the business processes. So this is what we have done so far. And for the paper, we will look at this. So supply chain innovations that perhaps start not with the objective of changing the business model, but over time they can develop into business model innovations. Okay, so the start is a supply chain innovation, and then it can step by step progress and evolve into a new business model. Okay, so this is the paper. So we are closing the loop in this way. Does it make sense? Yes? Okay. So, who had the opportunity to read the paper, perhaps? Okay, very good. So, many of you, this is great. So first of all, I would like to start with, because supply chain innovation has been defined differently by many authors. And in that paper, my colleague and myself were providing a specific definition of supply chain innovation, or a specific framework for supply chain innovation. Yeah, this is the supply chain, right? But the types or the dimensions of supply chain. Very good. First of all, the innovation is the one that would happen in a specific company. The implementation
implementation of a technology that should be already exists in the world, but not in a company. Why the question of innovation is divided between, as we said, technical innovation, operational innovation, and revolutionary innovation. Structural innovation is about taking changes about the configuration, and we can have examples such as the editing irrigation. Then about, for instance, the operational innovation is more about the changing of the flow of material. And then the revolutionary innovation is more about having a deeper changing.
Very good. And then we have revolutionary. So as we wrote the paper, we have been also struggling with defining what supply chain innovation is, and we come up with this framework. You see that it is a bit different from the framework from Albion and Al, but we use it because it is useful for the paper and for the purposes of the paper. And actually, okay, we started with concept innovation. That's structural. It could be configurational. It means we are changing the nodes in the supply chain. Perhaps we are adding a new node, like gross stocking by a Walmart. Operational, yeah, we are acting on the flow. Example, VMI is an innovation that tackles the flow of the supply chain. So VMI is vendor manager inventory. So the supplier is managing the inventory for the client. And revolutionary innovation here, what we wanted to say here is that there are supply chain innovations that are complex. So when you talk about GIT, just in time, for example, GIT it's not a single, small, very restricted innovation, but it is a concept that includes many aspects. So GIT, when we talk about green logistics or reverse supply chain, for example. So here we are actually including many types of supply chain innovation in order to come up with these, or in order to implement these. Okay, in technology innovation, there are many of them: EDI, RFID, GPS, IoT. Even Tetra Pak has been also cited as a logistics innovation, as in the packaging, which is very important, which changed actually the whole chain of the supply chain. Instead of having refrigeration inside the supply chain, inside the logistics, Tetra Pak packaging enables us to reduce this, or to delete it altogether, this refrigeration. Okay, so yeah, just as examples, EDI, RFID, GPS, aseptic packaging. I'm just write Tetra Pak, although it was just a trend here. Okay, so this is where we started from, and then so don't be confused by literature. Sometimes literature can provide many definitions for the same term. So this is very, very, natural, and it's very common. As I told you in our lectures, we will be using this. So not this, but yeah, this is an enrichment, let's say, of the concept that we know. Good. Then, yeah, what is the main observation in the article? The main observation.
I would say that many companies start from operational development and do supply chain innovations, and not start the revolutionary type of innovations. Very rare to encounter there.
So this is not an observation, this is a finding. So the article started with an observation.
I would say that the observation is that the reason that this small innovation is at a different potential level supply chain innovation.
Yeah, this is let's say a to find an approach to find a solution to the problem. But the main observation was that most of the examples of companies that we have in supply chain innovation, we have them also in business model innovation. And believe this is the way how we started writing the article. We said, examples of supply chain innovation are the same as business model innovation. So, and it was actually the trigger for this framework. Yeah, how comes that we have the same examples here? Like we are talking about the direct or the this intermediated supply chain of Dell, and on the other hand, we are talking about the direct business model of Dell. So it is a business model and it is a supply chain. And we found, yeah, IKEA is very present in the literature of business models, and it is also very present in the literature of supply chain. And then we started asking, yeah, perhaps there are some hidden relationships between supply chains and business models that at that time no one has talked about. And by the way, these relationships between supply chain and business model, at the time of the article, they have almost no one really talking about them explicitly. And this is what we wanted actually to do. Okay, then comes the next, I would say, approach that, or the approach that we took, and it is the approach of the operators. Could you elaborate more?
Yes, the operators that in business are used to make the approach to talk about supply chain innovation closer to the one that we use to talk about business model innovation. And the operators are like ways to transform a supply chain by, for example, eliminating or adding new activity or organizing that or innovating. So changing the graph of the structure of the supply chain by changing some of its elements. And this change ends up creating what is also the change in the business model of the company, changing its supply chain.
Very good. Please. Your voice high. Yes. Okay. Eliminate. The eliminate operator. Add an activity or an eliminate. Yeah. Add. Divide. Yes. Relocate. Yeah. Accelerate. Exactly. Very good. And there is one missing. Parallel. Very good. So these are called, yeah, operators. So look at the idea. The idea is, yeah, when you talk about supply chain innovation is very concrete. So we have, let's say, vendor managed inventory. We have the implementation of EDI or RFID. So we are talking here really about something that is implemented, that is operational, right? And then when we talk about business models or business model innovation, it is more or less a logic, a way of doing business, an idea. So from the abstraction level, this is more concrete, this is more abstract. So we cannot compare them or cannot put them together if we don't solve the problem of abstraction. We are comparing something that is very, very down to earth to something that is higher level. So we are not comparing same things here. We are comparing apples and pears, right? It is not useful. And then the idea was, how could we abstract supply chain innovation in a way that we can bring supply chain innovation more or less at the level of the business model innovation. And then it seems that we took many types of innovation, of supply chain innovations, we extracted them, and we found actually these operators. So supply chain innovations, at the end, according to our analysis, it would reduce to these operators. Okay, so we can think also, and this is just for thinking, that a supply or a business model innovation is a supply chain innovation at a higher level of abstraction. So we can use also these operators in order to innovate our business model. Right? So whenever we use them, because when we are abstracting supply chain innovation, we are coming at the level of business model innovation, and we can use this at the level of the value network of the company in order to come up with business model innovation. So supply chain innovations, they are influencing the business model innovation through these operators. So you may say, okay, at the supply chain level, this is, let's say, a crossdock. What is a crossdock? Crossdock is putting, let's say, a node between the supplier and the retail stores. Now, at a higher level of abstraction, this is about adding a node. Add node. Or add an activity, right? So adding an activity is here, from the activity system perspective of the business model, is a new type of business models, right? It is a new way of creating value to the customers. Okay, now for elimination, could you give me an example of company that used elimination? Yeah, very good. Adding. Walmart. With cross-docking, of course. Dividing. It's rather relocating. HP has done relocating. What did HP did? HP exactly. So it was not customization, it was localization. Because HP, before they relocate actually the packaging and final assembly of the printers, they have been doing everything in their manufacturing plants in Canada, in Vancouver. So they have been doing everything, right? And the problem is there is a long lead time between finishing the manufacturing and then really selling the product in Europe, selling the printers in Europe. Now, the problem was they had on stock, let's say they may have had on stock a lot of printers that are localized for France and too few for Italy, right? So there was always a mismatch between what the market needs, I mean, what France market needs, the French market or the Italian or the German market need, and what they had on stock. Why? Because they had to localize the printers a long time ahead of selling them. It is 4 or 6 weeks. We have to decide what the market in France would need, what the market in Italy. Now, what they did is that they produced only the generic printer in Vancouver in Canada. They shipped the generic printer in Canada. They waited until they had better data about the consumption, about the demand in France, Italy, Spain, Germany, whatever European country. And then based on that, they localize the printer. What does it mean? Localizing means they put the right charger, they put the right, the language, the right documents in the right language, etc. So it was like relocating some steps of production from Canada to the European warehouses And this is the example of HP. So dividing is somehow different. Dividing is when you have a part that is, you have a process, and you say, okay, this process may get customized products at the end. We may divide it in a standardized process. So this is we call it also the push process. And here it is the late customization, right? Which is a specific process. So we are dividing that process into one stable, standardized process and a late customization or customization process. So we find it in many companies. Yes, please. Benetton has inverted. So this is, it's very known also in literature. It is called operations reversal. There is a nice paper by Lee, I think in late 90s. It is called Operations Reversal in Management Science, where they are analyzing this concept of operations reversal from a mathematical point of view. So this is Benetton. You know what Benetton did, right? So instead of dyeing the colors or dyeing the clothes and netting, they knit the clothes in white and then they dye. So they inverted the processes. It is postponement, yes. It is postponement here, but by acting, a lot on the process, right? So what does it mean, postponement? Postponement meaning delaying some activities for later on. And here, postponement of the coloring process for later on. Because the coloring process is a process that is very fast. Instead of doing it really long time ahead of the market demand, because we don't know now what the customers in 6 months would ask for in terms of colors, it's better to delay that decision until, just to say perhaps 4 weeks, 2 weeks before the market demand emerges, and this way we can better fulfill the customer requirements in terms of colors, right? It is true. It is true. But relocate was for us why HP is the best example of relocate, because they got some steps in the process in the plant of Canada, and they relocated them really physically into the warehouses in Europe. So it is a relocation of activity. It is, of course, there is a division somehow. They said, okay, some of the elements of the process, we will be doing them later on. But it was not in the sense of customization. It was because they wanted really to send unlocalized printers, and then it was localization. There's a big difference between localization and customization. So I'm customizing perhaps for a client, I'm localizing for a market. So, and relocation, it is physical, right? So from here, in Vancouver, so we are getting some steps of the process and we relocate them to the warehouses in Europe. Dividing, you can do it in the same plant. You can have a manufacturing steps, which are standard, and then starting from the point of differentiation or first point of differentiation, you start making or differentiating the products according to customers' requirements. For example, let's say in the automotive industry. In the automotive industry, more or less all of the cars at the beginning, the body in white, it is called, it is the same. And starting from assembly, cars start to be different according to the requirements of customers. Without replicating anything, we are just, let's say, dividing the process into two parts. One that is standardized and one that is specific to the customer. Okay? And then we have parallelize. Parallelize. What is parallelize? Yeah, how could we parallelize activities? With which approaches? Modularity, exactly. Modularity. So here parallelizing, yeah, by means of modularity. And also if, I don't know, for the attentive reader, modularity induces specific structures in the supply chain. They are called pyramidal structures. So you have supply chains in the form of a pyramid, right? So you have many suppliers at the bottom of the supply chain, and then as you go to the top of the supply chain, of course, of the OEM, you have less and less and less suppliers. And modularity, of course, it is made on the product level, but it has a lot of good implications and positive consequences for the supply chain. In particular, the reduction of complexity from the perspective of the original equipment manufacturer. So instead of, let's say, an automotive producer to deal with thousands of suppliers, they're dealing with only a few modular suppliers or module suppliers, okay? And then accelerate, this is the, yeah, we are accelerating an activity, this is with IT, okay? IT accelerates the activities. Good. So these operators, right? It was the link between supply chain innovation and business model innovation. So you may think always, and this is a good thing, okay, when I have a supply chain innovation, I can try to select the right operator that corresponds to that supply chain. And in this way, I can understand what would be the influence on the business model. On the other hand, I can have a new business model. I can think in terms of operators. What does this business model introduce as new operators? And in this way, I can understand perhaps what would be the implications on the supply chain. Okay, now let's go a bit into the results of this study. What are the main results? What do you mean with innovation, incremental innovation here? Business model or supply chain innovation? Business model or supply chain? Business, exactly. So, and this is what we found. So we talked to many experts. So we have done 12 in Italy, 12 in Germany. At that time I was in Germany, so I have done the ones in Germany, my colleague did the ones in Italy. And then what we found is, okay, yeah, most of the innovations in the business model were incremental. But we were, of course, always interested in the influence of supply chain innovation on the business model. What we found is that, in general, companies introduce supply chain innovations in order to improve some operational performance. Let's say to reduce inventory, to accelerate or to reduce the lead time. But none of these companies had in mind a business model innovation. You see? okay, we have an operational problem, a day-to-day problem in our supply chain. We would like to solve it, and we implement something in order to deal with that.
But that is also about the reactive. It's not like the looks for innovation to implement, but face problems that when looking for a solution, like going to the innovation.
Very good. So it's rather a reactive approach. So non-companies use supply chain innovations in order to come up with the next big thing in business model. Please.
I would also add that technological innovation were usually as the enablers. And in general, that supply chain innovation. The objective is, yes, was commercial, but also the environment the business model, but without thinking about the directly. But for example, the games Walmart with said that we are patient and very people for banks to use their own way to
Exactly. So cross-docking as a supply chain innovation supports a lot the business model of Walmart, which is really focused on efficiency. It is an efficiency-focused business model. So the cross-dock was facilitating more, let's say, that business model. So most of the business model innovations emerging out of supply chain innovation, they are incremental. But very important is that supply chain innovation always has an influence on business model innovation, even if it is incremental. For example, by changing one single dimension in the business model, which could be the value proposition, it could be the value capture, the value communication, delivery, or creation. Please. Exactly, exactly. So this was, this is the idea that we've provided in the conclusion. So you can start from here in order to improve this, or you can start from here in order to see what kind of supply chain innovations may support you in order to implement that new business model. Exactly. So, very important also, supply chain innovations, they may become obsolete with time. Yeah, like the example of Dell. Dell, I remember in 2005, it was the #1 supply chain in the world. They had the highest performance. They were classified by the most prominent consulting companies as the best supply chain ever. And all of a sudden, because of the customer shift in preferences, because customers in general, in the meantime, when you would like to have a computer, would you configure it online? In general, no. You will go to the store or you go to Amazon and then you will just order that computer and get it. In general, I have never, for example, configured my computer on a website, so I just bought what is already out there, what is already on stock. Because people shifted their preferences. Because, look, Dell in the past was providing the possibility to customers to configure their computers, to make it customized, but at the same time, to buy the configuration they need. And this configuration they need happened to be, in most of the times, less costly than the one they would buy just from the store. Because you say, I don't need that very, very high performing processor. I will go for a slower processor because I would like just to have my computer for emails and for some basic stuff. Why buying really a very, very expensive one? But in the meantime, really, the computers became cheaper and cheaper. And Dell, the problem is that Dell cannot provide cheap computers because the customization itself costs a lot of money, right? So there are operational issues. They have to configure their process in a way that clients can get the customized computer. And therefore, they could not go low with the price. On the other hand, those that are making on stock, they could go very low in price. So more or less, the business model started to get obsolete, right? And the supply chain innovation was for a certain time, of course, very important and provided a lot of advantage to Dell, but then it was not anymore, and then they had to change, actually. Okay, this is about the conclusion, but still there is an important result I would like to discuss with you here in the findings, okay? So most of the innovations in the business model, they are incremental because supply chain innovation in general tackles day-to-day operations. So, but what is the other result that is important? Yeah, when you compare, let's say, smaller businesses and bigger businesses.
Smaller.
Yeah. Yes. You can go, and then you can.
Change their existing business model as a result of changing nutrition, but bigger, larger enterprises have this ability to extend their technology portfolio after introducing it.
Yeah, this is extremely relevant. These are two things inside. There is the so-called business model replacement. So you're replacing or you are improving an existing business model, or you can extend the business model. Would you elaborate on that? Would you want to elaborate on that?
Yes. Yes, sir.
There is another point. If you can. The example. Could you give an example? How large businesses perhaps can extend their business models with supply chain innovation?
Who developed tracking tool for its internal processes, and then it was well functioning, and they were able to market this and sell it and create additional business models.
Exactly. It's very good, very, very good. And this is an important insight that we got from the paper. Look, some companies, and it is also in line with what we found, what we said before. So most of the companies, when they implement supply chain innovation, they implement it to improve their day-to-day business, to improve their operations, right? But some companies, which are good and excellent, they may see that certain supply chain innovations, let's say in the logistics or in the supply chain in general, they could be important for other companies. Like this dairy company that was implementing a system inside its logistics in order to track the temperature of the dairy products that they are shipping. And they were using it just because of an internal need. So they needed that process in order to see, okay, during the trip, during the shipment, the dairy product, the milk product, they will not go below a certain temperature. So it was some time ago, right? And then all of a sudden they saw that other companies, they are interested in that technology. What they did is that they extended their business. So they are in the dairy business, they are selling milk products, and all of a sudden they started to be a technology company, right? They are advising, consulting other companies in need of that technology in order to track the temperatures of their trucks along the shipment. So starting as one company, right? So a dairy company. Then, of course, they continued with the same business model as a milk producing company, but now they are, let's say, a technology company also. So this is a new business model that consists in advising other companies that are in need of that technology in order to make other revenues. We have seen another company, it was, I think, DHL. DHL was doing the same. DHL, of course, this is a big logistics company. They are doing many things, but DHL started with experimenting with RFID, with radio frequency identification technology. You know, at the very beginning, RFID was not so widespread. Companies had to suffer in order to implement it. It was not so obvious how to implement it efficiently. And then DHL was one of the first companies that implemented RFID, but just for their internal processes. And all of a sudden, they saw other companies interested into what DHL is doing. Then what DHL did is that they created a consulting company that will advise other companies that would like to implement RFID in their processes. So starting from a logistics company, they are now a consulting company. I mean, of course, they continue to be a big logistics company, but now they are additionally, they extended their business model with a new consulting business model. And that business model, it emerged actually out of their, their supply chain innovation, their experiments with RFID. And this is very interesting, right? So a supply chain innovation that can lead to a new business model. Actually, that was it. So that was the brief. Any other question? Please.
Yeah. So
So, you can use it, of course, if you have the activity-based, you are using the activity-based of the business model. So, what you can do is, you start with the old, So the idea is like this. So there is the initial business model, and the business model is an activity system, okay? Initial business model. And there is, let's say, initial activity system 1. And so you have here, I'm just here drawing them as a process, as processes. So these are activity 1, 2, 3, 4, and 5. So this is the initial one, okay? And then by using the business model canvas, by thinking, by means of business model patterns, you come up with activity system 2. And this activity says system 2, it is another one. And you can look at the differences between this one and this one. In particular, you are looking at which operators have been used in order to transition from system 1 to system 2. For example, you may have added new activities. You may have eliminated some activities. You may have accelerated some activities. So you can come up then, in order to come from 1 to 2, I will use some operators. And this is add, invert, eliminate, and you should specify them, right? Okay, now you know exactly which operators you have used, and then you can think, okay, adding, I know from supply chain innovation a cross-dock, or it could be a warehouse, or, okay. then I know that for accelerating, I need some technology. So what kind of technology? Is it GPS? Is it EDI? Is it, you see? So this is the way how you may go from one business model to another. You identify the operators, and because we know, okay, what supply chain innovations are related to these operators, we can think about the concrete innovations required in order to facilitate or in order to get this new business. Does it make sense? Exactly. They go both. Exactly. They go both ways. Please.
I had a question about the small and medium enterprises. You said you were the one who introduced the German companies.
Yes.
So it's a bit of the one.
Exactly. Yeah.
Should also ask in Italy we have not very innovative companies. Same for the center maybe. And the main really states that small and medium enterprises are also not good to innovate their business model. So I believe that it improves how this situation in the industrial system of Italy is very difficult to overcome, because if you have not enough companies, if you have small companies, not only they are old, but they are also not improving, so the gap is get bigger and bigger. And I don't know if you have anything to propose about that, if you see a way around.
Yeah. Thank you very much. So, first of all, it was very interesting to observe how you started your contribution. You said Italian companies are not so innovative. So, no, it's not true. It's not true. By the way, the same we had in Germany. When we talk to the companies, the first thing they say, we are not innovative. They say this. Why? Because they have a very restricted definition of innovation. Look, and this is something that makes me sometimes really very angry, because they compare themselves to Apple, and they say, yeah, look at what Apple did, and then especially some years ago, and they came with the iPhone, and they came with the iPad, etc. Innovations that changed the world. But this is not true. I mean, innovation is not only about things that change the world. Innovation could be also incremental, and it is also very good. So this is the first thing. We speak also in the paper about, there's this classification, I think it is the OECD classification of innovation. There are 3 types of innovation: new to the firm, new to the market, and new to the world. New to the world innovations, you don't have them a lot. And really, many of the companies understand innovation as new to the world innovations, but this is not right. There are many innovations, like they are just new to the firm. By the way, if a company is accommodating an existing innovation, something that is existing, is just taking it inside the organization, this is called innovation, according to the OECD. Because believe me, it is not easy to accommodate an innovation. Yeah, talk to companies in Italy, in Germany, in Spain, in France, in Italy, whatever. When these companies have to accommodate, to implement an ERP system, SAP, for example, they have to be really, really, really very good in order to accommodate it, right? So this is the first observation. The second observation, our study is focused on 24 interviews. So we did not make, and we said that this is an exploratory conceptual study, so we are not making a survey in which we are comparing innovations in different countries. So this is not true. So it's just exploratory and conceptual. And still, by the way, this example of the company I told you about, the dairy company, this is an Italian company. Yeah, this is an Italian company. I don't remember the name. I'm sorry. So it was, yeah, we did the interviews. So the interviews were done by in Italy were done by 2015 or 6. So it was a long time ago, but it was an Italian company. So they are innovative. Any other comments, remark? So you have been today very participative into the paper discussion. Very nice. So, yeah, not all of you have talked. Unfortunately, you will get a bonus, you get a bonus, you get a bonus, you get a bonus. Yeah. You get a bonus, you get a bonus, you get a bonus. Yeah. So, it's not difficult to get a bonus point. So please, afterwards, during the break, just write your name on a piece of paper I'll give you. Okay. Now, let's go to the, okay, obviously only for the paper discussion. No problem. So we will talk today about supply chain analytics for supply chain innovation. Who has done a course on analytics before? Analytics, data analytics? Okay. Which software did you use? R, okay. Who has had another course? Yeah? In R. So, yeah, but you had to study R before, right? No? Okay, okay, yeah, because R is quite demanding, so it's even more demanding, let's say, than Python. But in this course, we will keep it simple. We will use Excel, okay? Because Excel, I think every one of us has experience with Excel. Who is using Excel every day? Good. Who has never used Excel? Okay. Who is using Excel? Sometimes, but yeah. Who is proficient in Excel? Who can say, I'm very proficient in Excel? Yeah, I'm always discovering new things in Excel, so yeah, I cannot say that I'm also proficient because you are always discovering new things. Okay, but what is important to me is more the modeling than the calculation. Still, the calculation, we would say how to do them, but the modeling or putting the exercise into numbers, in a way that we can solve it, I think this is most relevant. But before that, yeah. Okay, so yeah, why supply chain analytics? Yeah, there are advances in information and communication technology, greater availability of data. So could you imagine, for example, that you may get a lot of data from sensors, for example, where your trucks are out there, and then you can reroute the trucks real time. So this is really extreme relevant nowadays, and it will get more and more in the future, because we are talking in the meantime about supply chain twins, digital twins, right? So it's really amazing what happens, because you have the flows of the supply chain, you have trucks, you have productions, you have suppliers, etc. And then the supply chain, more or less, it is modeled, and you get the data real time into the model. The model can play with the data that are received right now, and then make decisions and provide instructions, let's say, to the driver of the truck to go another route, or not to start with the production of a certain component or certain product because the relevant components from the supplier will not be arriving in time, so we should prioritize another product. So it's amazing what is being developed. We don't have still the supply chain digital twin, but we are heading to it. At some point in time, we will have it. And it is nothing else than a model. Supply chain digital twin is a model that represents, of course, the real supply chain. But the thing is that it will get information from the real supply chain, and then it will send information based on the simulations that are done in order to optimize the real supply chain. So we can solve problems better by using this data. Here, what a study by Gartner that involved 144 people, I think, of supply chains. And yes, 144, 140. And people were asked about what are most important technologies for you. Yeah, digital business, advanced analytics, and robotic process automation. We will have time to deal with RPA. But the study shows that supply chain executives rated advanced analytics as the second most important emerging technology, right? So very, very important. Yeah. Why supply chain analytics? Why do we study supply chain analytics in a course on supply chain innovation? Because actually there are many frameworks, many studies, many researches that have been done so far showing that when companies are implementing supply chain data analytics, they're getting more innovative at the supply chain level. And this is one study done in 2022, and the researcher come up with this framework that supply chain innovativeness is depending on 3 or 5 main variables. Big data analytics is one of them. Big data analytics capabilities. Of course, we may have big data analytics stuff, employee development, etc. But big data analytics capabilities has an important influence on supply chain innovativeness, and supply chain innovativeness has or influences the supply chain performance. Yeah, we have another framework here. This is a research framework in 2021 that has been also validated with empirical data. Big data analytics capabilities improve supply chain resilience and supply chain innovation, which then improve supply chain performance. So you see how important the data analytics or supply chain analytics is for supply chain innovation. Now, another framework, yeah, it is a bit older, 2018, by Fernando et al. Big data analytics improves supply chain performance. It improves flexibility, responsiveness, reliability, and customer service. Supply chain innovation capabilities also improve supply chain performance, and big data analytics are improving supply chain innovation capabilities. So you see how important both are. So big data analytics or analytics improve the innovation of the company, or supply chain innovation of the company. Good. So this was just an introduction in order to put everything into context. So what are the types of supply chain analytics that we may have? We have the 3 classical supply chain analytics, which are very related to data analytics in general. We have the descriptive analytics. What has happened? So these are the questions that we ask. We use of data generated within the supply chains. We use quantitative methods in general to summarize the data. So for example, to summarize how good we have been, let's say, with our lead times to the customers. How many times did we ship our products on time to our customers? How high are our costs, right, etc. Predictive analytics, what could happen? So this is in general related to forecasting techniques, and prescriptive analytics. This is also extremely relevant because we would like to know what we should do in the future, right? How should we best respond to our present situation to the forecast future? For example, decision analysis could be used to determine how best to respond to the calculated predictions and observed conditions. Yeah. By the way, this is also what your navigation system is doing some prescriptive analytics. Given the situation of the traffic now, it will prescribe to you the best route in order to get to your destination as quickly as possible. So these are the three types of analytics. You find them not only in the supply chain, by the way, you find them in all areas. And we may have many, many different methods for supply chain analytics. We will deal with some of them, but not all of them. So you find here for descriptive analytics many topics like basic statistics or statistical distributions, etc. In predictive analytics, you can use forecasting, Markov analysis, theory of constraints, queuing theory, and prescriptive analysis, inventory management models, transportation, transshipment. Yeah, we will do some models. We will not be able to cover everything, but yeah, these are the methods that are used for descriptive, predictive, and prescriptive analytics for the supply chain. Good. Good. Before going to the next topic, I think we should have a short break, because next we will talk about something very important, which is base formula. Good. Let's do 10 minutes of break. 10 minutes. So now we have 9:47. We start at 9:57. Okay. We start at 9:57. Okay. The 10 minutes. Okay, as a preliminary start, I would say, for supply chain analytics, I will try to deal a bit with a formula that you know from statistics perhaps, and that you may have forgotten, Bayes formula. Who still remembers Bayes formula? Yeah, those who did analytics in the past? Bayes formula? Yeah. Okay. Bayes formula is extremely relevant, and I know that most of my students, they forget about it. But because of its importance, I will dedicate some time to it, because it's also inside supply chain analytics, and I will show you. I'll try to explain it in a way, hopefully, that you will never forget it, because it's so. It is intuitive. But if you just look at the formula of Bayes formula, you may discover perhaps it's a bit counterintuitive, or it's a bit difficult, but I will try to explain it in a way that is most intuitive. So Thomas Bayes, he lived between 1701 and 1761, extended the basic conditional probability approach and developed a method whereby fresh data or information can be used on prior probabilities to revise them and to calculate posterior probabilities. And the basic Bayesian process looks like this. So you start with prior probabilities, then you have the test assumptions. So there are some test assumptions that you use. Then you enrich them, or you get some new data, and then you can use Bayes process to revise the probabilities, and then you get the posterior probabilities. So this is what you may get in most of the statistics books, and then you get the formula afterwards. And I think it is not understandable, right? Who can make sense of this? Do you understand this? So by the way, if you open a statistics books, you may find this. Yeah, I know all of you have done already statistics, right? But all of you have forgotten statistics. Who still remembers statistics? Using it in everyday life, every day, okay, doing some statistics stuff? No, right. Good. Now, as I told you, because of its relevance and its importance also for the supply chain, we will see a supply chain problem that can be solved with Bayes' formula. I would like to, first of all, create an understanding of Bayes' theorem. So now here, forget about the formula, right? About Bayes and what I told you. Consider this scenario. It's not from the supply chain, it's just for introducing you to the idea. There is a disease that affects 1 in 1,000 people. There is a disease that affects 1 in 1,000 people. It means that 0.1% of people are affected, are sick. And then a medical test for this disease is said to be 99% accurate. So there is a test that when it is perhaps you make some blood analysis for the patient, or you do, or something, I don't know, so it's here not specified. But the test is said to be 99% accurate. Now, suppose if a person has the disease, the test is positive with probability of 99%. It is true positive. It means that if someone has the disease, the test will be, well, at 99% tell you that that person is sick. Right? If a person is sick, then at 99%, that test will tell you that the person is sick. But if a person does not have the disease, the test, of course, is not accurate at 100%. Person is healthy, but still, the test can give you a positive result. Okay? So the tests are not 100% accurate, and you will never find a test in practice in medical industry that has one. You remember COVID-19? Yeah, or some years ago. So the test was not 100% positive. So I mean 100% accurate. Sometimes it may give positive, but people still they may be they could be healthy, and it can say negative, although people are sick. But in 99%, I don't know the accuracy of the test, but it has a certain accuracy. Right? Do you understand the setting? Now, a person tests positive. Is it true that they have, or that person has a 99% chance of having the disease? This is the question I would like to ask you to understand your statistics intuition. So we have this information about the test, and then we test the person. So we find that that person tests positive. Is it true that 99% that person will have the disease? Okay. Yes. Very good. So we have to consider the false positives also. Yeah. Who understand what does it mean we have to consider the false positives? Because the test, look, there are 1 in 1,000 people are sick, right? Only one. So, and then if a person does not have the disease, the test is still could be still positive. And we have to take that into account. I will give you some small calculations. So first of all, before giving you the calculations, I will try to make sense of what meant by prior probabilities and posterior probabilities, what we have seen before. Prior probabilities, look, we have 1 person in 1,000 is sick. So what we believe about a random person, probability a random person has the diseases, the probability of having the diseases is equal to 0.1% or 0.0001. Okay? And then probability of a person does not have the disease. Probability of no disease is the rest. Which is 99.9%. Right? Now, we have test assumptions. And here we have the conditional probabilities. Very, very important. Do you know conditional probabilities? The conditional probabilities is like here. If a person has the disease, what is the probability that the test will tell us that it is positive, that the person is positive? It's 99%. It's 0.99. This means that, this is the probability of the person to be tested positive, given that the person is sick. So the person has the disease, which is equal to, this is the accuracy, right? This is the accuracy of the test. What is the probability of a person to test positive, although he doesn't have the disease? It is 1%, right? Are you agreeing with this? Now, we have the most recent data, which is the test result is positive. So the person, we know, the person is sick. Now, the posterior probability, and this is what we would like. So you see what we have. We have the probability, so this is from the test assumptions, probability of being positive given that the person is sick, probability of being positive given that the person is healthy. There is no disease. Now, what we are interested in, because we know now that the person tests positive. So what is the probability that the person has the disease given that the test is positive? So, and this is what we are looking for, right? And it is called the posterior probability, right? So here you see, very important in Bayes' formula, we have positive given the disease. So this is the test, our test assumption, but we are interested in probability of a person having the disease given that that person is tested positive. Now, let's look at the calculations. So I'm not using here Bayes' formula, I'm using only the spirit, the mindset of the formula. So over 1,000 person, 1 person actually has the disease and 999 people do not. Do you agree? This is something we got from the data. So we know that that disease will be present in only 1 single person. So on average, so from 1,000 persons, we would have only 1 person actually sick. Now, the one sick person, so, or that person that is sick, when we use the test, there is big probability, right, that person will be tested positive. So we have 1 out of 1,000. So that person that is sick, we test that person. So we will find him or her most probably positive, according to the test. Now, but out of the 999 healthy people, 1% will falsely test positive, and these are the so-called false positives. So that person that is sick, when we test him or her, we will find that they are positive. So this is a true positive. But still the test has an accuracy of 99%, so it is not 100%. So there will be some false positives. So people that are healthy, but still they will be tested positive. So out of 999, there will be 1%, although they are healthy, they will be tested positive. Meaning that about 10 people, they will be tested positive, although they are healthy. Do you agree with this? Do you agree? So what is the probability when a person tests positive? What is the probability that that person really has the disease? So once it is tested positive, he or she is tested positive, what is the probability that is having the disease? So it's actually, so we have only one sick person divided by how many positives we have? 11. Which is equal to about 9%. And this is amazing. So you find a person that is tested positive, this is the probability that the person is really having the disease. So it does not mean when some person is tested positive, that he or she is really sick or has really. The percentage is very, very low. So, the rest of the slide is nothing else than this. One true positive has 10 false positives. Total positive results 11. 1 out of 11, 9%. This is amazing. So it's a test. You use it on people. But, yeah, and this is the posterior probability, right? This is the posterior probability that we are. So these are the prior probabilities. These are the prior probabilities. This is the test assumptions. So positive given the disease, it's a test assumption. And this is, we have new information. The information that we got is that the person is positive. Now we calculate the posterior probability. So it's amazing. You have a person testing positive, the probability that that person has really the disease is only 9%. How good is the test? You can think of it. Now, look, it makes a lot. Now when you see this, it starts to make sense, right? So we start with the prior probabilities. Disease, no disease. So this is the information we have. Then we have the test assumptions. So these are the information we have about our tests. We get recent data. So this is the evidence. We have a positive. We use Bayes' theorem in order to calculate the posterior probability, which is 9%. So this is the Bayes process. Yeah, if you have any question, please ask me. Is it clear? Yes? By the way, in order to understand Bayes, don't try to memorize the formula. We will see the formula. The formula could be a bit or counterintuitive, or not counterintuitive, but it's hard to make sense of it. It is better to have this example in mind. Have this example in mind always, and then you will have an intuitive understanding of Bayes' theorem. Now, what we will do, we will try to solve a supply chain problem by using Bayes. Okay, so we have this setting, a gourmet restaurant tracks the supply availability of high quality ice cream depending on the average temperatures registered in every week of the year. For the last 2 years, Giorgio, who is the supply chain manager of the restaurant, has captured the following data. Now, we will have this situation. So what do you think? So we will make the difference between the distinction between temperatures during the day are superior to 30 degrees and temperatures below 30 degrees. Temperatures superior to 30 degrees Celsius and temperatures below 30 degrees. What do you think? During the time or the days where we have a temperature bigger than 30 degrees Celsius, what do you think about the supply of ice cream, of let's say specific ice cream? We will distinguish between high supply and low supply. As a supply chain manager, of course, you would like to get the ice cream to your restaurant in order to give it to serve your customers. What do you think? Intuition, when the temperature is superior to 30 degrees, would we have high supply or low supply? Rather low supply, right? So intuitively, we will have low supply, LS. Why low supply? Because there will be many restaurants, perhaps, that would like to buy the ice cream. So that ice cream will be in low supply. Now, if temperature is lower than 30 degrees, so perhaps people are not. So I like ice cream, by the way, to eat ice cream, whether it is temperature 30 degrees or it is 0 degrees. Even when it is 0 degrees, I'm very interested in ice cream because ice cream is great. Okay, so but there are people really they are associating ice cream with temperature. So when the temperatures are high, they eat ice cream. When the temperatures are low, they don't eat ice cream. In general, and this is intuitively, when the temperature is lower than 30 degrees, we will have high supply. So people will consume less, restaurants will buy less, and then you will find the ice cream that you would like to have. But, okay, so this is intuition. But perhaps sometimes, still, temperature is, so there may be exceptions. So still temperature is superior to 30 degrees, but we may have high supply, right? So this is something that we can get only from the data. But sometimes, I don't know, for whatever reason. And sometimes temperature is lower than 30 degrees, but still there may be exceptions. And we can have low supply. So just to tell you, it's when you are looking at your data, it does not mean whenever you have temperature bigger than 30 degrees, you will have always a low supply. You may have some days or some weeks where there is high supply, okay? And therefore, we have to generate this data. So, for example, Giorgio, our supply chain manager, has generated 104 data points. Why? Because Giorgio was looking at the last 2 years. So 2 multiplied with 52, 104 data points. So, for example, in week 1, the supply was low, temperature was bigger than 30. In week 2, supply was low, but temperature was lower than 30. Okay, so it depends. We believe in the data. Okay, now we will translate this problem into some probabilities. Now, Giorgio would like to get insights into the ice cream supply availability during the next weeks, based on weather forecasts. Knowing that in the next 2 weeks in August, temperatures will be more than 30 degrees, what is the probability of high supply? Okay. I would like that you tell me, okay, so here we are looking at the posterior probability, the probability of, I would have preferred if I did not have the answer here so that we can work out together the answer, but yeah, anyway. So, we know that temperatures will be bigger than 30 degrees. So, and then we would like to understand or to calculate what is the probability of having high supply given that the temperature is bigger than 30. Of course, as a supply chain manager, he would like to know what would be the availability of this kind of ice cream. Perhaps it's a very important ice cream, and perhaps he's doing this not only for ice creams, but he's doing it also for other products. Okay? So this is what we are looking for. Now, perhaps a short reminder. When we have B of A occurring given B, what is the formula of this? So this is conditional probability, right?
It's combination of A and B divided.
Exactly. So this is a very simple formula. This is the probability of A and B divided by the probability of B, which can be also formulated like this: A intersecting B divided by the probability of B. So it also makes a lot of sense. So given that B has occurred, right? What's the probability of A occurring? So this is, yeah, very, very intuitive that you have this. Yeah, I know that B has occurred. Now, what's the probability of A and B occurring at the same time? Yeah, we will go step by step here. So we analyze the data. So we find that we have 73 weeks of high supply. 73 weeks of high supply. So the probability of high supply, and then we have the probability of low, or we have 31 weeks of low supply. So the probability of high supply is equal to 0.7, right? And what is the probability of low supply? It is equal to 0.3, because 30% of the weeks we have low supply and 70% of the weeks we have high supply. So, you see, we need this. Right? We need to calculate this, so we are trying to interpret our data in order to come to this. Now let's do some calculations. So probability of high supply is equal to 0.7. probability of low supply is equal to 0.3. What is the, and since, for conditional probabilities, we need probability of two events occurring, A and B, probability of high supply and temperature smaller than 30. How we do this? Temperature smaller than 30, which is 55 weeks, right? So you see, we have here we have high supply. I mean, in the left-hand part, left side part, the temperature is smaller than 30. We have 55 weeks. 55 weeks divided by 104. This is the probability of high supply and temperature smaller than 30, which is equal to 55 divided by 104. Probability of high supply and temperatures bigger than 30. According to our data, we have 18 weeks where temperature is bigger than 30, and we are still in high supply. So it is the probability of high supply and temperature bigger than 30, and the probability is equal to 18 divided by 104, which is equal to 0.7. Probability of low supply, so we are going to the right-hand side. We have in total 31 weeks of low supply, but out of these 31 weeks, we have 6 weeks of temperatures smaller than 30. So probability of low supply and temperature smaller than 30 is equal to 6 divided by 104 weeks in total, equal to 0.06. And then probability of low supply and temperature bigger than 30, we have 25 weeks where we have both events, namely temperature bigger than 30 and low supply. This will give us 25 divided by 104 equal to 0.24. And now, the formula, which is the formula for conditional probability, I have already asked you about. Now, we need, of course, the, this, we go, in order to see, so once again, I represent here all of the data that we have with probabilities, to calculate the probability of high supply, given that temperature is bigger than 30. First of all, we need the probability of high supply and temperature bigger than 30, so we apply this formula. High supply and temperature bigger than 30, high supply and temperature bigger than 30, which we can read directly from what we have calculated is equal to 17, and what is the probability of temperature bigger than 30, because this one is equal to divided by the probability of temperature superior to 30. And this is equal to 0.17. Okay, for temperature bigger than 30, we need, of course, to add temperature superior to 30 and high supply plus probability of temperature bigger than 30 and low supply, because we have, when temperature bigger than 30, we have still the two cases, high and low supply, and this is equal to 0.17 plus 0.24, which is 0.41, and we divide this by 0.41, and this will give 42%. And this is actually the posterior probability, right? So we have the prior probabilities, high supply and low supply. We have then the prior probabilities that we have, depending on our data. So these are the test assumptions. And now we have the evidence. The evidence is that temperature, so the data in the next 2 weeks will be temperature bigger than 30, and we calculate the posterior probability, which is equal to 42%. So, what gets the supply chain manager? Given that the temperature in the next 2 weeks will be bigger than 30, the probability of being in high supply is equal to 42%. So this is all what the formula does to you. So as a supply chain manager, now you have to decide whether 42% is high enough for you or not. You may say, okay, It's okay. It's not a problem. 42% of high supply, I can still manage. Or you may say, okay, 42% is very low, and I have to look perhaps for other supply possibilities, other opportunities, because this is too low. So this also depends on the risk aversion or the risk affinity of the supply chain manager, whether 42% is for him or for her high enough or not. And this is, by the way, very important for AI, for all of these analytics. By the way, AI, what they give you some probabilities like that, right? And then based on that, you have to think and to decide. So if I tell you it is 40% probability that it will rain today, would you get your umbrella with you or not? Yeah, I hate getting umbrella with me because it's so annoying, so boring. I may forget it also in public transportation. I don't know where I may put it, so I don't like. So for me, 40% is still safe enough. Who would go with umbrella when you hear 40% of probability of rain? Yeah, you see? Yeah. You see, risk aversion is very different. So, or risk affinity. So 40% is high enough for you. For others, what's in it? For fidelity, what should be the percentage in order to get your umbrella with it? Over 50. Yeah, for me, I think it should be over 80. Yeah, over 80. So I go into the risk, of being under rain, and it's like that. So people are different. So, and what I showed you is really an application, again, of Bayes formula, of Bayes process for the supply chain. Look, in general, when you get an exercise, you may get this information. So you get the prior probabilities, which are P of high supply is equal to 0.7, P of low supply is 0.3, then probability of temperature. You see, temperature bigger than 30 given a high supply is 0.25, and probability of temperature superior to 30 given a low supply is equal to 0.8. And then, you are asked to calculate the posterior probability of high supply availability given a temperature bigger than 30. And to do the calculation, so when you get this, without the data, because I showed you the process step by step without needing the formula. Before we did not use the formula of Bayes at all. We just use the Bayes thinking. But now, we can, having this information, we can use the Bayes formula. It's exactly the same what we have done before. So these are the calculations from before. You get them directly, and you have to deal with this. So. Calculate the probability of A given B. Probability of A given B is equal to the probability of A and B divided by the probability of B. But the probability of B given A is equal to the probability of B and A divided by B and A. It's the same. And in addition, we have the probability of B is equal to the probability of B and A plus the probability of B and complementary of A. Right? So when you have, let's say here, A and B. Two events like this, A and B. And then you would like to calculate the probability of B. Right? So it is equal to the probability of A and B, right? So A and B, this is the point A and B. So when you get an element, it is at the same time an element of A and it is an element of B. So it's the probability of A and B plus, because we are looking only at this. Of course, we need this part, the probability that this part will happen. What we do, we get the complementary of A. The complementary is this, everything that is not A, right? So more or less we are excluding this part now. So this is complementary of A. So everything that is not A. So this is the intersection actually of complementary of A and B, which would be exactly this part. And you see that the probability of B is equal to the probability of A and B, and the probability of A complementary plus, and B. So we are using this formula, right? And then when you calculate the probability of A divided by B, so divided. Given B, it's not divided. I have to. So probability of A given B, it is equal to the probability of A and B divided by the probability of B. The probability of B, we know it. Yeah, this is the part here. And we use this formula. Probability of B given A, it is equal to the probability of A and B divided by the probability of A, meaning that the probability of A and B is equal to the probability of B given A multiplied with the probability of A. Right? And then we can use here the probability of B given A multiplied with the probability of A. And we can also express, with the same idea here, this, the probability of B, right? So the whole idea is that we have here the posterior probability A given B. We try to express the probability of A given B with terms that are using prior probabilities, which are probability of B given A. So we have the prior probabilities that we know, and we use them in order to calculate the posterior probability, right? So the whole thing, his whole transformation in order to transform A given B to B given A. Yeah, in the formula. And you can see B given A, B given A, B given A, and then here this is the posterior one. And we can apply this formula then, okay, in order to find the same result, which is equal to 42%. So you apply everything, so we have the data. A is high supply, A complementary is low supply, and B is temperature bigger than 30, and we would like to know what's the probability of high supply given that the temperature is bigger than 30, and we have then 42%, we find the same result. Is it clear how it works? So this is a reminder for the Bayes theorem, because I'm sure that you have seen it somewhere, right? Always prior probabilities. Then we have the test assumptions. This is the second part, right? And then we have the evidence. Temperatures bigger than 30. So this is the data that we know. The evidence. By the way, evidence, when you see evidence, this is the data that we got now. This is the data, the real data that we got. This is the evidence. So given the evidence, we would like to calculate the probability of, the posterior probability. And there are some startups, by the way, in the area of, I don't remember the name, but the big startup, it then got big. They're using artificial intelligence an artificial intelligence that is based on Bayes' formula. So when you go to the startup, it is an American startup, you find Bayes' formula everywhere. So whenever you have predictions, you have a system or a tool or an IT system that makes predictions, this can be called artificial intelligence, because artificial intelligence at the end, what it's doing is doing some predictions. You can do them with neural networks, machine learning, deep learning. You can do them even with a regression analysis. You can do them with Bayes' theorem. You can do them with forecasting techniques if you have time series, etc. So whenever you have predictions, this can be called AI. Because there is a discussion in the meantime. Yeah, everything is AI, but what is AI? And in this course, AI is about prediction. So we are using systems, mathematics in order to predict something. And predictions, by the way, they are always formulated in terms of percentages. Right? So if the AI gives you a 50%, what does it mean? Let's say, an AI can, let's say a decision tree, can tell you whether a client, let's say we are in the context of a bank, where a client that would like to have a loan, a credit, would be able to pay his or her credit afterwards. So it's more or less the trustworthiness for that person. At the end, what the decision tree will tell you, it will tell you at the end, this person has 60% or 70% trustworthiness. And it is up to the decision maker to decide whether to give the credit or not. Perhaps most of the companies, most of the banks in this case, they will have a threshold. 80%, the credit can be taken. Perhaps if it is between 60 and 80, there will be more documents that will be required. And then below 60, it will be a rejection of the credit application. So this is how AI works, right? And this is also what we do and what we will do in class. So calculating probabilities. Any question? Any remark on this? So if you get an exercise in the exam with Bayes' theorem, will you do it, right? Okay, I don't know what will be in the exam, so it could be nice, it could be not. But just it was a very, very simple question. Simple, friendly question. Let's put it like this. Simple, friendly question. Okay, so where can analytics be used? Analytics can be used in a supply chain in many areas. It could be applied in the strategy, for the strategy. It could be implemented to design the supply chain. It could be used in order to support execution processes. And could be used also to support supply chain people processes, right? So this is where analytics can be used. Now, what is supply chain strategy? Come on. The framework should really emerge in your mind. When you hear about supply chain strategy, there's something that should emerge in the mind. Come on, you are supply chain experts. You should know that. It was some time ago. It was about some weeks we did. Push, pull, and hybrid. Yes, this is one. But one of the most important frameworks is the one by Fisher, right? Please have it always in mind. When you hear supply chain strategy, have always in mind Fisher. Fisher has talked about two types of supply chains: the efficient supply chain and the responsive supply chain. So when we talk, and we will have an example about responsiveness afterwards, how analytics can support us in order to improve the responsiveness of supply chain, right? So here, this is about, of course, we should have some alignment with the overall strategy. So, if the company has a cost leadership strategy, so this is a corporate strategy, then perhaps that company should go for rather a an efficient supply chain. If the company has a differentiation strategy, they would like to be different from others, perhaps they have to think about, okay, whether the efficient supply chain could do the work, or they may go for a responsible or another, like perhaps for a differentiation, perhaps push and pull. But there is some alignment that should take place between the overall strategy of the company and the supply chain strategy. Then we have the design aspects. The design aspects, it is about designing the network. It's very, very important. The design of the network of the supply chain. How many nodes do we need? Let's say in the supply chain, we may have, and we will see examples, we will optimize supply chains in this way. Yeah, so supply chain has, let's say, a couple of plants, and they would like to increase the number of plants in a way to optimize the deliveries to their clients. So the question perhaps that we may have here, this is about a network problem. We would like to add a new plant to our network of plants. Where should we place that plant? In which region, right? And which optimization model should we use in order to support that decision? So these are design aspects of the supply chain. Then we have the execution aspects. Yeah, supply chain execution. So it is about production, it is about logistics, it is perhaps routing or rerouting. It could be a problem of transshipment. It could be a problem of solving or making the production plant faster, right? So these are all execution. So the idea here is to get reliable and speedy delivery. We can order much easier. We can improve the customer service, improve the order fulfillment, etc. And we can have also supply chain management aspects related to people. So a very important question is, what is the profile of the supply chain manager or leader that you need for your company? What should be the competencies of this manager that you will recruit in order to fit well to your organization? This is an important question, right? So you should think about the profile of people. Yeah, I have, for instance, at the moment, I have some of my students, they are working on their thesis about the role of supply chain managers in the future. Yeah, when we have more automation, right? I talked to you about this. When we have supply chain automation, that some of the tasks in supply chain management will be automated with the new technologies. What will be actually the role of the supply chain managers? Because some of the tasks will not be done anymore by people. They will be done by machines, right? So this is a big issue. So far, as I told you before, automation was focusing on the shop floor, was focusing on the warehouse. We have a lot of physical automation. Now, we have automation in the office. So things that people, negotiating contracts with suppliers. So in some new technologies, like smart contracts, they can automate negotiations between the client and the supplier, right? Yeah, between the client, between the manufacturer and, let's say, the logistics service provider. And there are also real applications of this. So these are things that have been done in the past by people. So if these are things that are done now by machines, what would be the role of people in the future? And if we know what is the role of people, I mean, for supply chain managers in the future, what are the kind of competencies that they should have, right? Perhaps people in the future, the supply chain manager would have to supervise the machine, to deal rather with the exceptions that AI or robotic process automation cannot deal with. Still, they are in the work or in the responsibility of people. But a lot of other tasks, they may get easily automated. So, and here, I mean, analytics could help us in understanding what is the best profile for a supply chain manager, or what is the profile of the supply chain manager that would have higher chances to get more successful in the organization. And we will see an application of this. Good. Yeah, before going now, we will do some exercises. Before going to the exercise, what about having 10 minutes of break, and then we will start with the exercises. And yeah, if you have Excel on your computer, prepare it because we will need it. Okay. Let's have 10 minutes. So we restart at 11. Okay, so we continue. We will do some examples now. Supply chain. We'll do some examples for supply chain strategy, supply chain strategy aspects, testing options, and then we will do some financial analysis of strategic supply chain innovation projects. Okay, let's look at this first situation. A data of sample of 121 recent. What does it mean, recent orders here? These are orders that are fulfilled by local. So X is the table that refers to hours of cycle time achieved. I mean here, you get the customer order, and then you fulfill the customer's order within a specific cycle. So F is the cost of each cycle time event, and your manager wants to know if the quoted order cycle time to customers can be safely reduced from current 32 hours to 28 hours. What do you suggest? So we have this data. So we need to make sense of the data. So here you have 421 orders. So the order has been once fulfilled after 14 hours, 2 times after 15 hours, so it is about the same order, obviously, 4 times in 16 hours. You can see 55 times that order has been fulfilled after 24 hours, and then only once it has been fulfilled after 34 hours. So intuitively, what do we want to have? Do we want to have a short cycle time or a long cycle time? Obviously, we would like to have a short cycle time. Now the question, what does it mean here? Your supervisor wants to know if the offered order cycle time to customers can be safely reduced from the current 32 hours to 28 hours. So what does it mean? It means that in the current situation, when the customer would like to place an order, places an order, you say to the customers, we will deliver in 32 hours from now. So you will get your delivery after 32 hours. It could be 32 hours, 32 days, whatever. So here it's not important the time. So, but 32 hours. Now your manager asks you, is it possible to quote instead of 32 hours, you quote now 28 hours to your customers. Instead of saying you will get your products after 32, you will get them after 28. So more or less here you are signaling more responsiveness, right? Say, we are more responsive, okay? you understand how important it is. So because 32 is longer, you have more buffer for delivering later. If you say, I will deliver in 28 hours, you should be faster. Right? And the question, given this data, is it possible that you code for customers, or would you code for your customers 28 hours instead of 32? How should we proceed? Yeah, this data, you can really get them very quickly from every ERP system in the company. So you can see for it, you start with a company, and you can get this data very quickly. So because they will be for sure in the ERP system, and then you can start playing with the data. So would you code 28? Or at least how would you proceed, and why? Very good. So you came up directly with the right answer, but believe me, when I ask this question to many of my students, they tell me, yeah, and please do not do that. We calculate the average. And then depending on the average, yeah, we can decide whether we go for 32 or 28. So if 28 is, let's say, close to the average, we go for it. This is something you should not do at all. Please do not trust the averages. We should calculate actually the service. So what is the probability actually that our delivery, so this is at the moment, so what is the probability that we will stay smaller than, or our delivery time will stay smaller, and then what we would like to calculate is what is the probability that we go from this to this. So look at this. So let's imagine, and this is purely assumption, that we have a normal distribution, right? So here we can plot everything here. So we start, I don't know, with we calculate the average. I don't have it in mind, but we will calculate it. Let's say we have a normal distribution. Normal distribution, it is a bell curve. It looks like this. Okay, here we have the average. Yeah, it is not for sure that we have a normal curve here, but we assume that we have a normal curve. We have, for 14, we have only one here. Then, this for 15, we have 2, etc. And then I think it is 24 is the we have here 24, which is the average, etc. So it is a kind of this curve. Then we will have 28, and then we have 32. So this is and then at the moment we are here. So we are quoting 32, and your boss would like to know whether we can code 28. And obviously the probability of the delivery time smaller than 32, which is the area that is below this curve, is bigger than the probability of having the delivery time smaller than 28. So when you are quoting 32, the probability of meeting that delivery time is higher than when you are quoting 28. Meaning that your reliability with the supply for the customer, it will be high. Your delivery reliability will be high. So, and therefore, this is a strategic decision. So you should only do this, only if the probability of having a delivery time that is smaller or equal to 28 is still big enough for you. Right? So, and this is the main idea. So you cannot, so for example, if let's say 60, 60 will be here. 60, the probability of fulfilling 60 is very, very high. So it is almost 1. But of course, your customers may not be happy with 60 because competitors, they are providing very good or much slower delivery time. So here, perhaps your competitor is delivering 28, and based on the data, now you have to examine whether it is possible or not. Now let's do the calculation. So what we should do, we should, of course, first thing, calculate the average, and we have to calculate the standard deviation, right? And we will do an assumption on this data set is that we have a normal probability distribution of the order delivery time. I would like to underline this many, many times, that in practice, it may not be the case. And before using the normal distribution, you have to demonstrate at the very beginning, that it is actually a normal distribution. And there are some tests that software packages provide you, like the Smirnov-Kolmogorov test, that shows you whether this distribution is normal or not. Because if it is not normal, you cannot use it. You cannot use any of the formulas that the normal distribution enables you to do, okay? So what should we do? First of all, we have to calculate the sample mean and calculate the standard deviation. Another thing here, which is extremely relevant, and all of my students, they make the same mistake. So what do we have here? We have a sample. So when we calculate the average is equal always x bar equal to the sum of x i's divided by n, which is the number of observations. So this is the average. This is very clear. Now, what is the formula of the standard deviation, right? Yeah, let's say sigma. What is the formula of sigma, standard deviation? You start calculating without, 1 second, I will give you some time to calculate. Just give me the formula of the standard deviation.
Minus the average. Beta 1 minus the average. Divided by the number of small.
And then?
Divided by.
But if you will add this up, it will be equal to 0 at the end.
Yeah,
Squared. Very good. And then?
Divided by number of times, number of data points.
How many data points we have here?
121. Yeah.
Very good. So when it is a sample, because when we divide by n minus 1, it is a better estimator of the population's standard deviation. So here we have the sample standard deviation, which is equal to S. But what we try to estimate, the sample's population, the population's standard deviation, and therefore we have to subtract 1. Many of my students, they forget this. Don't forget this. Okay, and there is also something we should not forget. Exactly. So this is the formula of the standard deviation. So first of all, what we should do is that we have to calculate these. And you have the Excel. I'll just stop sharing for a second. I'll do the exercise with you together. I prepared the table in a way that easier to follow. So we will calculate the standard deviation step by step. So here we should be bearing something in mind is that in the data we have the frequencies, right? For example, for x equal to 20, we have 22 data points where x is equal to 20, okay? So we have to take this into account. So first of all, for what we have to calculate is that we have to calculate x multiplied with the frequency, as if we have been saying, okay, it is 1 times 14 plus 2 times 15, so it is 14 plus 15 plus 15, and 16, it is 4 times plus 16 plus 16 plus 16 plus 16, 4 times, etc. So I have to put it here, yeah. It's always a bit complicated because I have a German keyboard. Now it's good. So I'm multiplying x with f. I'm getting this number and then I will be pulling down so that I'm calculating it for every. You have the Excels, by the way. If you have the Excels, you can, did you have it? Yeah, very good. Did you download the Excels, all of the Excels? You could do the exercise the same time I'm doing it on the board. Now, what we can do here is that we can calculate the average. Sorry. So it's equal to I'm calculating the sum is better. Sum so this is the sum. Here we can calculate also the sum here. This should be 421. Okay. Yeah, it's a bit late. Should I make it bigger or is it okay? Better this way, right? Okay. Are you following? Are you doing with me everything? Now we can calculate the mean. Yeah, it's simple. I'm detailing this. Of course, we have shortcuts in Excel, but just to be sure that every step is done correctly, and then and then we have the mean. The mean is equal to 24, which is this one, but divided by the sum of x. Now I will be calculating. Of course, I can do it everything in one step, but I will do it step by step. It's better. So I will calculate the x minus. So the x is here. This is x, which is the order delivery time, minus the mean, right? And I should put the dollar symbols here. The dollar symbols because when pulling down, it should be fixed. It should not change. right? And then I will be pulling down, so Excel will be going line by line, but will use always the 400, the 24, right? So, and we can control, and everything is right. Are you following it? Are you doing the same here, or? Yes? But so the 24 is this one divided by this one. So this is because these are x multiplied by f, because x happens f times, okay? And then here it is 421 data points. Did you find the results? So with tablet perhaps it's a bit more difficult than with computer, right? But do you manage? Okay. Then we will go and then we will do the square. Okay, equal to x minus the mean squared. So I will put it here because, yeah, this is how you are making a square in Excel. So this is, I have it, it is D2. And then you have like a hat, right? This is the hat, this is the square. Like a small hat, and then when you put 2, it means D2 will be squared. And it is 100, and then I will be pulling down again. And then I will multiply with f, because yeah, it happens f times. So this is in my data set. I have 421, so 81, let's say, yeah, 100 here. It happens one single time, but let's say 49, it happens 7 times. So I have to add this, or to consider this. So it is f multiplied with x minus mean squared Okay. So what I'm calculating now this term. I have calculated this term. Right? I have calculated these terms, and now I have to sum everything, and then I will get the sum of this. So I'll be summing all of these numbers, and I will get this 4,978. Yeah, there's a bit of delay, so it's always like this. And then what should I do to calculate the standard deviation? So I know Excel can do it very quickly. I'm just putting here the formula step by step. What should I do now? So I have calculated now, I introduced the sum. So this is this number. So I have to divide with n minus 1, which is 420. and then apply the square root. So the square root is SQRT of this sum divided by the number of points, which is 421, minus 1, and then I am closing 2 times the parentheses. So this is the formula, SQRT, square root of F23 of this number, which is the sum of the xi minus x bar squared, divided by B23. Yes, B23, which is 421, because we have 421 in our sample, but minus 1 in order to account for the fact that it is a sample standard deviation. Great. And this is my standard deviation, which is equal to 3.44. I can make it a bit elegant. Yeah, it's too many numbers here, right? I can click here, and then I will reduce the number of numbers after the comma. Did you reach this stage? Who could not reach this stage? So I have the cycle time current and cycle time nu. The cycle time current is equal to 32, and then the cycle time nu that we would like to test is equal to 28. Now I will calculate the Z values. How are calculated the Z values? The Z values, because I would like to use the standard normal distribution. So I will have our statistics expert.
The value the subscript
The X bar.
by the mean and divided by.
Very good. So when we take this one, so this is the probability of x minus x bar divided by the standard deviation, which is smaller than 32, minus x bar, which is here, 24. And then once I do this, I can use the standard normal distribution with a mean equal to 0 and standard deviation equal to 1. So let's calculate the current Z value, which is for 32 minus the 24. I have to put it between parentheses, divided by the standard deviation. So this is the formula. You can see the formula there. So it is H2. So it is 32 minus 24 divided by 344. So Excel is really great because it shows us all of the cells that have been used for the formula, right? So 32, 24, and 324. And then I get the first Z or Z, as you want to pronounce it. And then we have the Z nu, which is equal to 28. Should not forget the parentheses. Make the right division. Plus, minus the mean divided by the standard deviation. So again here, you have the formula I2 minus B24 divided by M24. So you see the current, and we calculate the new Z value. And you can see that the new Z value is smaller, right? As I told you, we are going here. It's much smaller. You can make it a bit more elegant because I think it's better. Now we have to calculate the service level. It is actually the service level. It is our capability of promising a delivery time that we can really fulfill. So if we promise 28 and we cannot fulfill, this is a big issue, right? Still, it would be better perhaps to promise 32 and to fulfill it than to promise 28 and not be able to fulfill it. So now what we are interested in is to calculate the area below the curve for x, for 28 and also for 32. For 32, we would have a bigger probability, very, very obvious. Now, we will use the normal distribution. So the standard normal distribution, okay? And very important, we suppose here, we assume that it is a normal distribution. Do not do it in the practice in your company if you are not sure that it is a normal distribution. Otherwise, you have to find perhaps a better distribution that fits better your data, or to apply other methods. Okay, now I will use the standard normal distribution, which is this one. Okay, so you see normal dot or norm dot s dot dist, standard normal distribution. This is the acronym. So I will take this Z, and then I'm interested in the cumulative distribution function, not in the probability density function. You see, Excel asks me whether I should put true or false. True is for cumulative distribution function. False is probability density function. I'm not interested in the probability density function. I'm interested in the cumulative distribution function. Is true. Did you achieve that? Could you reach that? And then I will be pressing on enter. And wow, so when coding 32, the probability of achieving 32 hours is about 99%. This is a service level equal to 99%. So the company will be always below 90, not always, 99% of the cases, they will be below 32 hours. Now let's go and do calculation for 28. And now we'll see the level of reduction in the service level. So we do the same thing, same type of formula, standard normal distribution. Then we have the Z, which is 162, and then true, because I'm interested in the cumulative distribution function. And then our service level is equal to 87.74%. My question now, what would be your answer to your boss? Would you do it? Would you go for it?
I don't think so.
Juan, you
Like,
don't? Yes.
service level of 95% has been. I mean, that level is really high, but I mean, I don't think so.
Very good. Very good. So let's say, what does it mean to have 87, let's say 88% service level? It means that in 12% of the cases, we will be beyond 28 hours. And 12% of the cases is not low, it's not low, right? So if I were the supply chain manager of this company, like Juan, I would not recommend this. I would rather recommend, perhaps, to start with a supply chain innovation project with the objective of reducing the lead time, reducing the cycle time, in a way that when we are quoting 28, we can achieve a much better service level. Otherwise, it could be a big issue for the company. Here, it could be really a big issue. 12% of the orders will not be fulfilled in time. Okay? So we have to be very, very careful. We have to do all these steps. We should know the mathematics behind in order to do this. Okay, so yes, please.
Average cycle time by almost 4 hours. You provide the same service level.
I don't know. We have to recalculate everything. So, I mean, here, if they reduce on average, let's say, if the average go from 24 to 20, and then it depends, of course, on the distribution, we have to recalculate this, and then you can do it as an exercise at home. So it's very good exercise. So you can try to play with the numbers a bit in order to reduce it, and then recalculate and see. And yeah, you can then, based on these calculations, you can define the target for a supply chain innovation project to say, our target is to reduce, let's say, by 3 or 4 or 5 hours, the cycle time, with the objective at the end to be able to quote 28 hours to our clients and still having a good service level that we can accept, let's say 99%. 98, it depends on the company. Okay, we come back to ours. So, of course, the first set of slides that I uploaded does not contain the solutions because it is meant to be interactive, that we do everything together. But when we finish the supply chain analytics part, I will upload all the set of slides with the solutions, the interpretations, etc. Okay? I will do it after the lecture of next week. Okay, so here, yeah, these are more or less the results that we found, and yeah, as I told, as we discussed before, yeah, a process improvement project must be put in place before perhaps quoting the 20 to 28 hours to our clients. Now, so we did that. We will do another example for supply chain strategic aspects. So we will do a financial analysis of strategic supply chain innovation projects. So many techniques exist for the analysis of projects. From a financial point of view, the most important analysis techniques are net present value, internal rate of return, and the payback period. Okay. Now we have, yeah, you can see also chapter 3 because we have done yeah, an introduction to this. Good. A microchip manufacturer, it is called Premium Chip, so this is the name of the manufacturer, determines from recent customer surveys that its customers would really value a reduction in the offered order cycle time. So the customers would like to have a reduction in the cycle time. The surveys indicate that customers would increase their buy levels from Premium Chip by 15% if order cycle times could be reduced from the current 3 days to 1 day. So it is very related also to the problem that we have done before. Now, initial calculations indicate that such an increase would boost free cash flows by $75,000 per year over an expected 5 years. This is the period estimated for competitors to catch up. So for 5 years, we will be having an advantage. We will be quoting a better cycle time to our customers, and customers are ready to pay more if they get a shorter delivery. Now, the project cost, so this will come at a certain cost. The project cost of achieving such an order cycle time reduction would be a once of $250,000. So you have to pay, people, personnel, perhaps for equipment, etc. So you have to set up a project that will cost you $250,000, and then you can, for 5 years, get $75,000 as advantage from your customers. So customers will be paying more, or they will increase their buys. Then Premium Chip wants to know if such a level of expenditure represents a good investment for its available funds. And we will do this for 2 cases. For the case where perhaps the equipment that is used, that is purchased to implement this project will have a value of 0, or it could have a rest value. So we will do it for 2 cases. So you are hired as data analytics consultant to calculate all financial performance indicators related to the supply chain innovation project, the net present value, the internal return rate, and the payback period. You decide to conduct the analysis using 2 scenarios. The first scenario with no terminal value, with no rest value, it means at the end of the project, any equipment used is valueless and cash flow benefits cease, or in the second scenario with a terminal value, in this case, there is a cash flow benefits beyond the appraisal period. So we can go now to, you have in your Excel many tables. So we are done with table 1, with sheet 1. So let's go to sheet 2 in the Excel. I stop sharing for a second. Okay. This is the new Excel. Is it big enough? Okay, this is big enough. Okay, we have in period 0, we have a cost of 250,000, so this is minus 250,000. Then every year, 1, 2, 3, 4, and 5, we have a cash flow of 75,000, and we will treat one scenario with the terminal value, without the terminal value, and then the other scenario will be by using a terminal value equal to 65,000. Yeah, all what we will do now is that to calculate the cumulative present value. So we have a a rate equal, or an I equal to 10%, so meaning that, yeah, we need 1 plus I, which is equal to 1 plus, no. Okay, so this is the term that I need, which is 1.1. Okay, and I will do the calculations with that. So for the present value, so for the spendings minus 250,000 will stay the same, it will not change. Now for the present value, what I will do is that I will get this 75,000 and I will divide it by 1.1. So this is actually the value of 75,000 with reference to today, to the day 0 when I made the spending, so to year 0 when I made the spendings. Now, I will do also the same. I can do it in 2 different ways, but I will do it in a simple way. So here is to the power of 2. Then this one divided by 1.1 to the power of 3. Same thing. Yeah, I could have done it much faster, but I do it this way. Divided by 1.1 to the power of 4. 75,000 divided by 1.1 to the power of 5. And then this depends, of course, on the scenario, whether we are working with scenario 1 or scenario 2. So 65,000 divided by 1.1 to the power of 6. Make sense? Yeah? So this is the formula of the net present value. I try to calculate the cash flows with reference to the starting point, right? By using the discount rate, which is equal to 10%. Discount 1.1 with a rate equal to 10%. Okay, now I will calculate the cumulative. So this is equal to C4, but I will be using the plus the one after, and I will be so this is the cumulative net present value. At the beginning, at year 1, it should be the same value, so it is 68,000, and then I add 68,000. I put in the formula C6 plus D4, and then Excel will always, when I pull out on the right hand side, we'll use this the same logic in order to fill out everything. Now the net present value. Could you tell me the net present value? What is the formula? I would put exactly what I'm doing here. Ooh, it should be C6 plus D4 is right. Okay. What is the formula in order to calculate the net present value without terminal value? Give me the formula, I will just write the formula. It's equal to G6, right? Which is the cumulative value after 5 years, minus, not minus, because I have already a minus 25,000 plus the spendings that we made at the very beginning. And this will give me a net present value without the terminal value equal to 34,309. And then I will calculate the net present value with terminal value. And it is easy because I will use H6, which is 320,999, and then minus 250,000, which is plus 10, because I have already the minus sign, D3. And obviously, I have a bigger NPV when I have a terminal value. So normally we should start this project. We have an NPV bigger than 0. We have to start this project. But now that I would like that we calculate the internal return rate of a project. Good. So we have used here an I equal to 10%, right? So and the discount factor was equal to 1.1. But let's say if we get a I equal to 15%, meaning that we have a discount factor equal to 1.50. So of course, the net present value will go lower. What we are interested in here is that to calculate the internal return rate, meaning that we would like to calculate an I in a way that after the 5 years, our project will just cover the costs. Okay? So we would like to calculate R, or would like, so this is the question. Calculate I, we would like to calculate an I, so that we have a net present value at year, or cumulative net present value, cumulative net present value at year 5 equal to 0. So this is the internal rate, the internal return rate. Is it clear the meaning of the internal return rate? Of course, we will find an internal return rate that is bigger than 10% here, right? Because with 10%, we have a positive net present value. So if we increase the discount factor, then our cash flows, discounted cash flows, they will be lower. And yeah, we will have an internal rate value. So, and the internal rate will be for sure bigger than 10% because NPV for 10% when we calculate is superior to 0, right? So we would like to calculate I that will lead to a cumulative NPV that is equal to 0. How could we do this? We can do this, by the way, with what-if analysis. Look at how we can do it. So I would like to, I'll do it before without without the terminal value. So I'll go to data. No, I should not put anything here. I should go to data, and then I go to goal seek. And then I would set this cell, which is the I would set the I as the one that I'm looking for. No, I'm sorry. I would like to set NPV equal to 0. I would like to set NPV equal to 0. So this is NPV, which is without terminal value. I set it equal to 0. And I will change cell C1. Do you understand this? So I'm telling Excel, please set NPV equal to 0, and then please vary I in a way that we can find the NPV equal to 0. So I'm looking for a value of I that will lead to an NPV equal to 0. And then Excel will do the calculations. It's okay. And I can put it in percent. So when I have an I equal to 15%, you see my NPV will be equal to 0. It means that, what does it mean? It means that I would accept an interest rate, that is lower than 15%, because all I's below than 15%, they will lead to an NPV that is bigger than 0. But after 15%, if I have an interest rate that is 16, 17, 18%, this will not be possible anymore to accept the project because they are bigger than the IRR, they are bigger than the internal return rate. Is it clear? And then we can do the same also for the NPV with terminal value. I go to data, to what-if analysis, goal seek. Then I would like to look at this cell. I'll set it to 0 by changing this cell, which is the interest rate. And you see, now it is NPV with terminal values equal to 0, and then we have a I interest rate equal to 19%. So it has increased. So when we have a terminal value of the equipment, still projects that say when we use a interest rate of 17%, 16%, 18%, it's okay. At 19%, we will be at 0, so there will be no benefits from the project. At 20, 21%, of course, the project should not be done because the costs will be bigger than the cash flows. So you can write here, yeah, IRR1 is 15%. And IRR2 is equal to 19%. Those are our calculations. And now we would like to calculate the payback. What is the payback? Payback period. This is the period of time required in order to get NPV, so the cumulative net present value equal to spendings. Right? So when do we achieve break even? In matter of time. And here we can, by the way, solve it graphically. So, first of all, I will put the years 1, 2, 3, 4, 5, and then I will select. I will use use the first scenario without the terminal value, and then I will put the cumulative. So I'm selecting 1, 2, 3, 4, 5, and I'm selecting them, the cumulative values, 62,115. So I'm selecting them. And then I will be putting everything, I will be drawing the curve, a chart. This chart. Oh no, this is a bad chart. Insert. Why is it like? Normally this. Why doesn't? It's I'm sorry, I have to go back here. This is why it doesn't work. 0.1. I have to do it once again because I have to use the original numbers. Yes. Yes. So I would. Yeah, my mistake was that I was working with NPV equal to 0 before. Yeah, this was the problem. And now I will, this is cumulative NPV chart. So I have the number of, you see, so I have the number of years here, so the years, and then I have the NPV on the y-axis. So the first thing I did is that I draw the chart. And then there is a very interesting function in Excel. I can go here, I click on one of the points, and then I will say to Excel, add a trend line. So, and then I will use an exponential, I will use a polynomial trend line, and then I will say to Excel, please display equation on chart. So I use a polynomial, but I will use a power. It's better, I will choose a power. It's easier for calculation. And then I will say to Excel, display equation on chart. You see, Excel will display the equation on chart. Will show that y, which is the cumulative NPV, is equal to 69,139 multiplied with x, which is the number of years, to the power of 0.8. 0.8 is too small here. 8898. Okay. So it's very simple to get this. So I have a y equal to, could you please tell me the equation? Oh, didn't you find it? No? 8898. Yes. So what I will do in order to get, how do I do it? So I will, yeah, and I will set this equal to, yeah, to the spendings. Yeah, I'm sorry, I raised it. So I'm interested in the payback. So I'm interested in the X, so that I have, so here it is the number of years. That will give me cumulative NPV is equal to spendings. And this is the cumulative NPV because I plotted the cumulative NPV. And I have to set this to 250,000, right? So it means that X08898 is equal to 250,000 divided by 69,139, meaning that, okay, I have to the power of 1 divided by 0.8898, I have also put this to the power of 8898, and this would be equal to x. Can someone do the calculations for us? So you see in the curve, where would it be? So you see here, so we have 250,000. It would be 4, so 250,000. It would be 4 and something, 4.1, 4.2. We should find 4.2. So after 4.2 years, we break even, and we have more or less compensated all of our spendings through enough cash flows. Very good. So 424. So it is after 4 years, 24. You can calculate the number of months. And if you see the curve, right? So this is our cumulative NPV, 200. So it should be. So graphically, it's the same as 420. 24. Yes, please. Yeah, you can have different. Yeah, depending on what kind of approximation you're using. Here, I use the power approximation. So it is a power line. So you can use it. Actually, not. No, it's not. So there is a mistake. So if you use another function, so like a logarithmic function or a polynomial function or whatever, yeah, you may find. I use the the power function because it makes things very simple. So, but you can use other ones, and you may find also the same thing. But if you use the same function as a selected, so yeah, you should find the same result because the numbers are the same. Yeah. Is it clear? Yes? So if you missed a step or so, you can look at it at home, and and then you go through it once again. And this is simple. But next week we will do some simulation with Excel. You will see that Excel can make some very interesting simulations. We will do also some optimizations by using linear programming. But for today, we are done. Thank you very much for attention, and then we will continue with the other examples in our calculations for supply chain analytics next week. Thank you.